This is a demo of the Ganttnavigator model that has been developed for simulating and managing construction projects. We have chosen a power plant as example and defined 4 work packages. Starting with the civil work, there are input data like the scope of work, planned duration of the work, and both planned and estimated workforce productivity. Having a workforce limit of 20 people and a lower productivity than planned for gives us a 33% underperformance. If we allow for a higher workforce limit, say 35 people, we can see that we retain the project duration of 11 months. We can then add a reference curve to compare our 2 scenarios. In addition, we get several other important pieces of information, both planned and actual, like the progress curves of the work, the effort in man-months, and the expected direct cost. The example of civil work shows that in case of underperformance and if no other constraints exist, then the increase of resources can compensate and close the project in time. The next work package we will look at is the structural work of the heat recovery steam generator. Similarly to civil work, we see the requested workforce distribution and an actual 25% lower productivity than the budget one. Running the simulation, we find that the target workforce has a topology of a linear structure. The control function keeps the target time by increasing the resources over the target. Worth mentioning is also the output of the demobilization dates. The third work package of the power plant model refers to the piping assembly work. The simulation is once again similar to the other 2 work packages, but the main difference is that the topology structure is exponential and that the actual condition foresee a constraint of maximum 50 people due to the leveling condition. The control system will try to finish on target, but due to the constraint and to the lower productivity, a delay is unavoidable. The last work package of the power plant model refers to laying the electrical cables. In this case, the actual productivity is higher than the budgeted one, and in addition, we are assuming a limit in the incoming workforce flow and in the maximum amount of workforce. Using the project network table, you may decide a work sequence same as we do in a Gantt schedule. We can change the overlap between activities, but if we increase the overlap between work packages, then we shorten the overall construction time, but we also decrease the productivity. This means we will get lower indirect cost, but a higher direct cost. Now we may look at the overall results when the work packages are simulated together. You will see the target and actual values we have mentioned before, but now they are accumulated for the full project. And on the cost page, you will see not only direct cost for the work packages, but also indirect cost as well as the total project cost. Last but not least, you may apply a Monte Carlo simulation to analyze how your project responds to uncertainty. We have added an uncertainty factor for the actual productivity, and the graph illustrates the probability of achieving our target using different percentiles.